Hello friends, welcome to today's lecture Stress and Strain. Lecture number 3. Myself, Mr. Y.S. Patil, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering, Yatra. In this lecture, we studied numerical on method of superimposition and stresses in the composite section. So in previous lecture, we studied find out the change in length of a different section acting a single load on the particular bar. In this section or in this problem we studied the different section and different loads acting on the particular sections. So let us see one problem. A member ABCD is subjected to the forces as shown in figure. Find the force P and net change in length of the member. Take E is equal to 200 giganewton per meter square. So this is a problem given. AB, BC and CD, this is the three parts. For AB is a 1 meter having size 40 by 40. For BC is 1 meter having size 20 by 20. And for that CD is 1.5 meter having size 30 by 30. It's subjected to different loading, that is 120 kilonewton at section A, 220 kilonewton at section B, and at point C there is a load P, and at point D there is 160 kilonewton. So first of all we identify this value P. So how to calculate this value P? By equating summation Fx is equal to 0. The algebraic sum of the all horizontal forces should be equal to 0. Total number of the forces in the system is 1, 2, 3 and 4. Out of these 4 forces, 120 kilonewton going towards left side, 220 kilonewton going towards right side, P going towards left side, and 160 kilonewton going towards right side. So put up all right side forces one side and on left side forces one side. So 120 and P going in a left direction, so we write here, and 220 and 160 kilonewton going towards right side, so plot in this side. So in this total equation unknown term is P. So P is equal to 260 kilonewton. So P value is 260 kilonewton. Now we calculate forces acting on the each element, that is AB, BC and CD. So first consider section 11. This is a section 11. Listen carefully. Now we calculate forces acting on the each section. So mark a section 11, and now this body is split into two sides, that is right side and left side. Total number of the forces on the left side is 1, that is 120 kilonewton, and total number of forces on the right side is 1, that is 220 kilonewton, that is P is equal to 260 kilonewton and 160 kilonewton. So total number of the force on the right side is 3 and on the left side is 1. So summation Fx is equal to 0. Now 120 kilonewton on the left side, put up 120 kilonewton. On the right side total number of forces is 3, that is 220, 260 and 160. So 220 going towards right side, that P going towards left side, so consider minus 260, and 160 going towards right side, so plus 160. So 220 minus 260 plus 160 is equal to 120 kilonewton. Now see here, right side is equal to left side, that is 120 kilonewton going towards right is equal to 120 kilonewton going towards left. So an answer is positive. So member AB is subjected to 120 kilonewton force in a tension. Then next consider section 22. Once again, now this is the section number 22. This body is divided into two sides, that is right side and left side. This is the left side of the body. For left side of the body, two forces is there, 120 kilonewton and 220 kilonewton, and on the right side of the section is, that is P is equal to 260 kilonewton and 160 kilonewton. Once again summation Fx is equal to 0. On the left side, two forces, that is 120 kilonewton and 220 kilonewton. So 120 minus 220, and on the right side there is two forces, that is P is equal to 260 going this direction, so my answer minus sign 260 plus 160. So now check here, minus 260 plus 160 is minus 100 kilonewton, 120 minus 220, that is minus 100 kilonewton. So right side is equal to left side, but now negative sign, that is minus 100 kilonewton. So minus sign indicate compression. So this BC portion is subjected to 100 kilonewton force in compression nature. Now consider section 3.3. Once again, this due to the section 3.3, the body split into two sides, right side and left side. Now on the left side, this is three forces, 120 kilonewton, 220 kilonewton, and P is equal to 260 kilonewton. And on the right side, that is 160 kilonewton. So summation Fx is equal to 0. So 120 minus 220 plus 260 is equal to 160. So answer will be 160 kilonewton is equal to 160, and the answer is positive. So nature of the force is tension. So this is the final forces subjected to AB, BC and CD. The AB is subjected to 120 kilonewton force, that is tension in nature. BC is subjected to 100 kilonewton force, that is compression in nature. And CD is equal to 160 kilonewton force, that is tension in nature. Now plot separate free body diagram for each section AB, BC and CD subjected to particular loading. That AB is equal to 120 kilonewton tension, BC 100 kilonewton compression, CD 160 kilonewton tension. Means change in length is AB and CD is increased and change in length for BC is decreased. So this is plot as positive sign, and for that BC subject plot as a negative sign. So total change in length delta L is equal to change in length for AB plus change in length for BC plus change in length for CD, and delta L is equal to, we know the formula for change in length, that is PL upon AE for AB, PL upon AE for BC, and PL upon AE for CD. So for AB, P force, already we know that P force is 120 kilonewton converted into Newton, that is 120 into 10 raised to 3. L is 1 meter, area is 40 by 40, and E for this overall means AB, BC, CD is a common, that is 200 giganewton per meter square. So for AB, P is equal to 120 into 10 raised to 3, L is equal to 1000 mm, area is equal to 1600 mm square. For BC, P is equal to 100 into 10 raised to 3 Newton, that is compression. L is equal to 1000 mm, area is equal to 400 mm square. And for the CD, P is equal to 160 into 10 raised to 3 Newton, that is tension. Length is equal to 1500 mm, area is equal to 900 mm square. And E for this AB, BC and CD is common, that is 200 into 10 raised to 3 Newton per mm square. So we know that change in length is equal to change in length for AB, for BC and for CD. The equation for that change in length is PL upon AE. Already value of the PLA for AB, BC and CD. Put up all these PL upon AE values in this equation and calculate the change in length. For that change in length for AB is 0.375 mm positive. For BC 1.25 mm, that is change compression means that is negative, and for that CD 1.33 Newton 1.33 mm, that is elongation, that is positive. So by considering sign, sum this delta L AB, delta L BC and delta L for CD is 0.455 mm, and that answer will be positive, means change in length is in elongation. So this is the final solution for problem, and this type of the problem called a superimposition method. Next we can find out stresses in composite section. Means best example for composite section is the RCC column. A RCC column is subjected to two materials, this is basically steel and second one is a concrete. So load carrying capacity of the column is equal to load carrying capacity of the steel and load carrying capacity of the concrete. Both load carrying capacity are sum of this both loads are same. So let us see, this is the load subjected to means this is a two bars, that is A1 and E1, A2 and E2. A1 means area of the outer tube, this is the A1 section, and corresponding that E1 means the Young's modulus for outer tube. A2 is the area of inner tube, this is the A2 material, area of the inner tube, and E2 is the Young's modulus for inner tube. Sigma 1 means stress in outer tube and sigma 2 means stress in inner tube, and this is the length for this both material or both tubes are same. So total load is equal to load on the outer tube means load on this tube plus load on this tube. The summation of these two load is equal to this total load. So total load is equal to means we know that the stress is equal to P by A. So P is equal to stress into area. So P is equal to sigma 1 into A1 plus sigma 2 into A2. Means load carried by the material 1 plus load carried by the material 2. So change in length in the column is equal to, that is strain is equal to change in length upon original length. See, this is the original length. Due to this dead load, somewhat length is reduced. So both material are reduced in a same quantity. So strain in material 1 and strain in material 2 is same. So change in length is equal to delta L by L is equal to sigma 1 upon E1 is equal to sigma 2 upon E2. So sigma 1 is equal to sigma 2 in brackets E1 by E2. This E1 by E2 is nothing but that is a modular ratio. So by using this equation number and equation number 2, we can easily find out stress in material 1 and stress in material 2. So let us see one problem. A concrete column 400 mm square area and is reinforced with 4 steel bars of 20 mm diameter, carries an axial load of 1000 kN. Determine stresses in each material. Take ES is equal to 18 EC. So first of all, mention given data, the area of the steel, the 4 bars of steel bar of 20 mm diameter. So 4 into, that is pi by 4, that is 0.785 factor into 20 square is area of the steel is 1256.63 mm square. So AC area of the concrete is, that size of the column is 400 mm square. So I want to calculate net area of the concrete. So how to calculate net area of the concrete? So area of the column minus area of the steel, that is area of the column is 400 square minus area of the steel is, that is 1256.63. So net area of the concrete is 158,743.37 mm square. And ES is equal to 18 EC. It is nothing but that given modular ratio. ES by EC is equal to 18. So by using this equation, we got sigma S is equal to 18 sigma C. Means stress in steel is equal to 18 times stress in concrete. So total load carried is equal to load carried by concrete plus load carried by steel. And we know the PC is equal to sigma C into AC and PS is equal to sigma S into AS. So total load on the column is 1000 kilonewton, means 1000 into 10 raised to 3 Newton. So PC is equal to that sigma C into AC. Area of the concrete is 1,58,743.37 plus sigma S. We know that converted that sigma S is equal to 18 sigma C. Means we, instead of that sigma S, we can easily write that 18 sigma C, and area of the steel is 1256.63. In this total equation, unknown term is only sigma C. So sigma C value is 5.51 Newton per mm square. If you know that value of the sigma C, we can easily find out sigma S. That sigma S is equal to 18 into sigma C, and we know the value of the sigma C is 5.51. So 18 into 5.51 is equal to 19.25 Newton per mm square. This is the value of sigma C and sigma S. You can easily find out load carried by the concrete if they are given stresses, or if they are given load, we can easily find out stresses in the material. Okay, thank you.